All right, today we'll be looking at graphing quadratics in standard form. The first thing we want to do is find our x-intercepts. The x-intercepts can be found by either factoring or doing the quadratic formula. I'm going to try to factor first. I prefer factoring over the quadratic formula. I think it's a little quicker and a little easier. So first, x times x is x squared, and then we need to think of multiples of 3 that can have a sum or difference of 2. 3 is prime, so we know that our factors are 3 and 1. And to get a negative 2x, we would need a negative 3 and a positive 1. And 1 times negative 3 is negative 3. So from here, we need to solve our parentheses are 0, and we get x equals negative 1 and x equals 3. And so my x-intercepts would be negative 1, 0 and 3, 0. I'm not going to put the points on my graph yet. First want to find all my points so they get an idea of how big the graph is going to be. The next point we want to find is our y-intercept. And so the y-intercept actually it's quite easy to find in a quadratic in this form. The y-intercept is always the c value. It's always your c, it's your constant. And so in this problem here, our y-intercept is negative 3, or 0, negative 3. And we can double check that by just plugging a 0 in for all of our x's. And so if we take 0 squared minus 2 times 0 minus 3, we'll see that 0 minus 0 minus 3 is negative 3. Also, the next point we want to find is our vertex. The vertex uses a formula, the opposite of b over 2 times a. Now this gives us the x of the vertex, and the y of our vertex is f of negative b over 2a, which simply means for us to figure out what the x is and then plug it back into our equation. And so it's important that you can identify what your a and b are in your equation. And here my a, being that there's nothing in front of x squared, we know our a equals 1, and our b equals negative 2. So the opposite of b, so since b is already negative, we'll make a positive 2 over 2 times a, which is 1, and 2 over 2 equals 1. And so that is what we're going to be substituting into our equation to find the vertex. And so our equation, we take 1 squared minus 2 times 1 minus 3. And so that is, this step here is the negative b over 2a. And so, or the f of negative b over 2a. So we get 1 minus 2 minus 3, which gives us a negative 4. And so at 1, negative 4, we have a vertex. Now we have enough information to start our graph. And so go ahead and draw our y-axis and our x-axis. I know that my y-intercept is 0, negative 3. So go down here to negative 3 and put a point. And our x-intercepts are at negative 1 and 3. We know our vertex is at 1, negative 4. Okay. Another important thing here for us, and it's going to help us out get our 5th point, because we want a graph with 5 points typically, is going to be our line of symmetry. And the line of symmetry is the equation x equals negative b over 2a. So if you've already found your vertex, you already know what the negative b over 2a is, and we found that earlier, and we got 1. So x equals 1. Anytime you have an x equals equation, it's going to be a vertical line. And this vertical line is always going to go through the vertex. So if you can remember that, it's a quick way to get your vertex, or to get your line of symmetry. The line of symmetry helps us because using it, we can get an extra point. And so I'm going to zoom in here on our graph. If you notice, right here is a distance of 1. So we also have a point, a distance of 1 on the other side. And we can use that point to help us draw a nice U-shaped graph. And so there's a graph of our parabola. Also want to note that the domain of a parabola is all real numbers, and it's always all real numbers. Or you could write negative infinity to infinity. Okay, it's going to go forever left and right. Now the range for our parabola is going to depend on the vertex, which in this case is a minimum. So this is our vertex, it's a min. And the lowest it goes is -4. And so we're going to have y is greater than or equal to -4. So all your y values are going to be -4 or greater. Another way to write this would be from -4 to infinity. All right, so let's look at our next example. In this next example, we want to look at factoring as our first method to find our x-intercepts. And when we go to factor this, 13 is a prime number just like 3 was, so 1 times 13 are only factors, and there's no way to get a sum or difference of 6. So quickly we see that we can't factor this, so we're going to have to use the quadratic formula. And so again, we need to identify our a as 1, our b as -6, and our c as 13. And a is always in front of x squared, b is always in front of x, and c is always our constant. And so it's the opposite of b, so our formula is -b plus or minus the square root of b squared minus 4 times ac all over 2 times a. And so our b is already negative, so we can say plus or minus the square root of -6 squared minus 4 times a, which is 1, times c, which is 13, all over 2 times 1. And so we get is 6 plus or minus the square root of 36 minus 52 all over 2. So 6 plus or minus the square root of -16 over 2. The negative that we get under the square root means there's no solution. You can't take the square root of a negative number. And so we get no solution, which means no x-intercepts. No x-intercepts. But we still have a y-intercept, and our y-intercept is still the c value, so we get 0, 13 as our y-intercept. Our vertex, we're going to use the -b over 2a, and since our b is already negative, then we'll do +6 over 2 times a, which is 1, and we get 3. And now we need to substitute the 3 back into our equation, and in doing so we get 3 squared minus 6 times 3 plus 13, and so that's 9 minus 18 plus 13, and so here we get a -9 plus 13, which is a +4. So our vertex is 3, 4. And just let me note that the a value being positive, I know that my graph is going to open up, and so this is what opening up looks like. If a had been negative, then it would have opened down, so this is opens up, and this would be opening down. All right, and so this is when a is positive, and this is a negative a, which we don't have here in an example. All right, so let's go ahead and start our graph. If you notice the y-intercept is 13, just pay attention to that because you may need to adjust your where you locate your graph on your paper. I know that 13 is all the way up here at the top, so 2, 4, 6, 8, 10, 12. Here's my 13. There are no x-intercepts. Our vertex is at 3, 4. So 3, 4, we have a vertex. Our line of symmetry our line of symmetry goes through the vertex, so that's going to be x equals 3. And so we're going to have the imaginary dotted line coming down the middle. We have a, well, we don't have any other points. And so the line of symmetry helps us out tremendously here because it gives us, there's 3 points, we're 3 to the left of our line of symmetry, so we know that 3 to the right, we get another point. Now I said that we want a graph with 5 points. And so the best way to do this is to pick the nearest whole number to the left or right of your vertex. And so our vertex is at 3, so the nearest number to the left or right is either 2 or 4. It doesn't matter which number you choose. I'm going to choose 2. And so if we take 2 and plug it back into our equation, and so we're looking for extra points here, plug a 2 in, 2 squared minus 6 times 2 plus 13. We get 4 minus 12 plus 13. And so that's negative 8 plus 13 gives us 5. So at 2, 5, we have an extra point, which would be right here. And if that's 1 unit away on the left, we have a point 1 unit to the way on 1 unit away on the right. So that would tell us if we had plugged a 4 in, we would also get 5. And so now we have enough information to sketch our graph. And we're done. All right, guys, I hope this helps you. Thank you. All right, we forgot domain and range. So again, domain is always all real numbers. So we can go ahead and write all real numbers. And then our range, again, uses our vertex. And so our minimum point, because it's opening up, is 4. So we know that all the y values will be 4 or greater. So we can say y is greater than or equal to 4, or you could say bracket 4 to infinity. Make sure if you're using the brackets that you know that the least number is always on the left and the larger number is always on the right.